Our presenter today is Chris Lawson with Argus Health. Argus Health is owned by DST Systems, and DST Systems provides information processing software and services to the mutual fund, insurance, retirement, and healthcare industries, and they generate an annual revenue of approximately $3 billion. Chris is an application architect with over 17 years of mainframe development experience. His specialty is bringing legacy systems into a modern architecture. And with that, I'll hand over to Chris.
Thanks, Farrell and Susan. I appreciate the opportunity to share how Argus has used HostBridge to incorporate into our overall API strategy. As you've already introduced, Argus Health System is a wholly owned subsidiary of DST. DST is in two sectors. They have the financial sector, which is the mutual fund industry, the finance industry, and then the healthcare industry, which is where Argus Health Systems falls. Argus is a pharmacy benefit management company. Primarily, we process prescription claims. We do 2 to 4 million claims per day. That's our core system. In our development environments, we are a very mature mainframe shop. We have a lot of knowledge and experience in CICS, COBOL, DB2. We run on a Z13. Because we are a mature mainframe shop, our developers do have a very deep understanding of our core businesses, developing those applications in the CICS and COBOL environments. We have a lot of web services. Currently, our architecture is in Java and SOAP. But what we found with our development environment for web services is that it's very long in development cycles. We have difficulty in deploying and configuring. Part of that difficulty comes from having so many test environments. We have 26 test environments and then a production environment. And I believe our test environments may be growing to 27 within the next year. Our web developers typically are not familiar with our core systems, so there's a disconnect in understanding how things work under the covers in our core systems. We have noticed over time that there is an increased demand for our web services. Last year, we logged 1.5 billion web service calls, so we know that we needed to come up with a strategy to be more agile and develop these more quickly. So we came up with a vision for our web service development environment. We wanted to incorporate REST in our architecture, developing APIs and microservices. We wanted to look at JavaScript. JavaScript to us seemed to be easy to learn, but not only that, it had a large online community. There was a lot of documentation out on the internet that we could reference and go to, rather than some of the newer languages that didn't have much or very little to go off of. We know we needed to become more agile like any other company. We needed to decrease our time to market so that we could stay competitive. And with those in test environments, we really needed to simplify our deployment and migration strategy. Looking at the REST architecture, it's an architectural style of application programming. It uses data interactions rather than an implementation. So any type of language can call any type of language. Java can call JavaScript. JavaScript can call anything. And it just focuses on interactions via data rather than the implementation of an application. The REST services are stateless and simple and are typically invoked through HTTP verbs, get, put, post, delete, very, very simple. They're very language agnostic, meaning any type of language, COBOL, Android, Java, Ruby, C#. They can call REST services, and as long as they can speak the language through the data context via XML, via JSON, or any type of data implementation, they can speak to the REST service and understand what it's saying. It wakes up, does its processing, and passes back the response. Microservices are something we really wanted to get to because they're simple, they're single function, They're organized around capabilities rather than big applications or big products. Because they're so small and because of the REST services, they can be written in different languages, access different databases, reside on different hardware. With microservices, you can always have a continuous delivery. They're easy to develop. They're very small. You deploy them. If you have a change to one part of the application, you really don't have to change very much other than the one single service or maybe a couple services. And with that, they are very easy to replace. You can swap them in and out as needed, which I stole this from some web page, and it really shows kind of the evolution of web applications. At least from our standpoint, this is how we kind of transitioned. Back in the 90s and earlier, it shows here that it was a monolithic application. Any web application was very tightly coupled. One change to one part of the application meant lots of changes across the board. 2000s introduced a service-oriented architecture. There was looser decoupling, but still one change to a part of the application meant changes elsewhere. Microservices really opened it up to smaller changes, smaller areas that were impacted, easier deployments, more opportunities in deploying and changes with less cost. After we determined our strategy, we looked at products, and HostBridge stood out to us. Because we are a mature mainframe shop, server-side JavaScript was on the mainframe was really attractive, which is what HostBridge JavaScript is. It's server-side JavaScript for our mainframe. It's zip eligible, helping reduce costs in processing. It is JavaScript, so it is easy to learn, and there's a large online community. There's a lot of documentation. Our open systems developers were already familiar with the language, and what we found is that our COBOL developers picked it up very easily and had no trouble understanding how to use JavaScript. It's Eclipse-based, making it very, very easy to use and deploy. One thing that stood out to us was the deployment strategy. We already, with our mainframe, had a very established approval process and migration with our COBOL development in Endeavor. And HostBridge JavaScript was able to hook into Endeavor, and we were able to use the established process for deploying these services, making it very simple for us to deploy to all regions using a process everyone's very familiar with and a product that everyone's familiar with here. And not only did we think that HostBridge JavaScript was good in that fact, but it helped us expose some of our core functionalities. Applications that were written long ago could now be wrapped in a REST service and used outside of the legacy systems. We found that to be very, very beneficial. This I stole from HostBridge's website. It shows how, it helps illustrate how we use it. We have servers that connect into some of these REST services using TCP/IP, and we have some applications that run on the client that come in the same way. They interact with HostBridge, and they have that data context, the XML or SOAP or the XML HTML. We mainly use JSON. We found that was a lot easier to use. But it goes into HostBridge, and it processes, exposing a variety of data sources on our CICS platform, all the applications. We have not used MQ, but we're interested in starting to use MQ a little bit more. But this really shows kind of how it interacts with our systems very well. I've put together a couple of examples of how we've used HostBridge JavaScript in our real world. The first example is RESTful integration with a third party. Formularies are drugs that are covered under a benefit plan, and those formularies are really hard to manage. There's a lot of drugs and a lot of different variations of drugs and how they interact with your benefit plan. There was a third-party tool that we decided we wanted to use. It was widely used in the industry, and we needed to be able to integrate with it very quickly into our claims processing system. We developed a HostBridge integration solution. We created RESTful APIs that they embedded in their product, their third-party user interface. Those services take the information from that tool, feed it into our system, into our DB2, using HostBridge services in JSON. We developed around 7 services to integrate with this third party, and it really only took us about 3 weeks to complete. Very, very, very attractive. A Java and SOAP implementation would have taken much, much longer. And we were able to take this product, integrate with it, and get it to our users in around 3 weeks. Internally, another example, we have a lot of 3270 macros. Those online screens that we've developed over time, there's a lot of teams here that need to get information from those screens. So they've developed VB macros in Excel that hit the 3270 screens repeatedly to transfer information into Excel so that they can verify that the data that was entered into the screens by another team actually is what we expect. The 3270 macros are very high in processing volume. They go out and they hit the 3270 screen over and over and over again. There's a lot of overhead in doing that just to verify that the data entered was correct. What we've done is we've taken HostBridge, we wrote one service, and it retrieves the data all in one interaction. The request to HostBridge is made on the mainframe. We've taken the DB2 out of the 3270 screens and put it in the request. It pulls the data, delivers it to a simple HTML page using JSON, and the quality teams now are able to verify online with less overhead. There was a lot of constraints around when they could use these macros, so it didn't impact our production systems. That has gone away with these web pages. It allows them to do their work without any constraints, and the overhead is very, very attractive. Another reason we're doing this is our long-term strategy is to remove these 3270 applications, and those macros created a dependency keeping them around. So hopefully over time we can transition all of our macros into a REST service like this and be able to sunset our 3270 applications. A third example was we took a lengthy process internally. Our call center would receive requests to reissue member cards. The call center would take the request over the phone, create a list in Excel, and send that list to another team internally whose purpose was to take that list, feed it into an ad hoc batch process that updates a single column on the member record, and that column is reissue yes or no. So the value indicates whether it needs to be created or not. Then another nightly process wakes up, reads in all those records for the members that need new cards, and processes the reissues. What we were able to do is create a simple internal tool using an HTML page that calls HostBridge Web Services on the back end. It takes in a small amount of information, the same information the call center associate would put into the Excel spreadsheet, and instead of sending it to another team for extra processing, it just sets that column using DB2 on the back end immediately with feedback to the user so they can know whether or not that member ID was correct or not. It removed the need for multiple teams, reduced cost, and it reduced risk for human error. With HostBridge JavaScript, it's JavaScript. So a lot of the tools that we were reading in the industry also applied to us when we started using it. We started using Subversion. SVN is our version control. It helps us track changes to the source code, helps us deploy a little bit easier, understand what's been made. Putting it in SVN allows us to use OpenGrok as a searchable code base, a lot of these things we were already using in our web environment, and we were able to port them in and use them as if they were an open systems JavaScript or Java implementation. If you've read anything about API development, Swagger always comes up. And we've been able to document our APIs using Swagger. It's really a slick way to go out there and document your APIs and test your APIs and catalog your APIs. So we were really attracted to being able to use this with HostBridge. And then some of our testing, we use Postman, which is a Google extension, allows you to do REST calls. SoapUI also allows us to do that, save off testing, do automated testing, and things like that. It's really helpful for us. And then the biggest one for us was Endeavor, our migration, simplifying our migration. Those test environments, getting it out there without anything but an automated process to push it to the various locations. And I think I went through that pretty quickly. I apologize, but if there's any questions, I'll open up for questions and discussion right now.
Okay, Susan, let me know that it looks like everyone came in via their computers today. No one dialed in to the call, so let's just quickly check and see if there's any in our chat window. No questions in chat, so Chris, you did a great job of explaining what you're doing, and it sounds like a very complex environment.
Thank you.
Chris, thank you. As I mentioned earlier, we will send out the slides in a slide deck, so look for that email from Susan. We also have recorded this, so if you want to socialize that or perhaps view it again, please just reply back to Susan, and we'll be glad to send out the link and the password. We love to do demonstrations of HostBridge and talk with potential use cases. So if this has triggered some questions about HostBridge or a potential use case, please just contact myself, Farrell Johnson, or Susan, and we'd be glad to schedule a call. And we'll include one of our technicians, and we can just go as deep as we need to technically in discussing potential use case and your computing environment. We also do free pilots, so if you're interested in doing a pilot of HostBridge, so you can actually see HostBridge working with your applications, we'll be glad to work with you on that. Again, we do that at no charge. Well, Chris, again, thank you for sharing a few of your use cases and how you're using HostBridge in the real business world. And with that, we will conclude today's webcast. Thank you, everyone.
Thank you very much.